Okay, hello. This is Dr. Janes, and today I'm going to talk about how to take our sonar-controlled Bobot robot and make him kind of autonomous, a sonar-controlled robot, so it can go and explore the areas of your living room or kitchen or whatever without colliding with the walls and map it out. So here I'll show you how it works, and then we'll talk about the code for a little bit. Okay.
That's me, but
Okay, so we have our Arduino program up, and I modified NewPing from the NewPing library for the Sonar on the robot, and I talk about that in one of my other videos. We do a short script to control the ping, and we've modified that to make it a little bit better. And so here's our new IDE, and I might try to see if I can put this in the YouTube description. It may be too long, I don't know, I haven't tried that yet, so we'll see. If I can, I'll try to stick it in there. So let's start with the let's go through the code. So we have at the beginning include, and then the first one is newping.h. It's a library for the sonar on the robot. And then we have an include for the servos, because we want to control the servos, and these are continuously turning servos, so when you send pulse with modulation to them, it controls whether they go forward or backward and how fast they go, but it's not like a normal servo where they have feedback and it tries to go to that spot. I guess there might be feedback, but it's a velocity feedback, and if anything. So we're going to define a trigger pin, and I'm going to use 9. In the original example they're using 12, and an echo pin we'll define 8, and the original example was using 11, so I put those over here so I can remember. Now those other pins are being used with a different apparatus that I have on the robot, which is not being used in this program, but I wanted to be cleared up because I wanted to be able to stick all these different things on the robot and have it do fairly complex tasks. We can define a maximum distance. It can sense in theory up to 400 centimeters, but it takes longer for the algorithm to run when it's trying to wait for that long to censor or sense that distance. And so we set it to 200. And so here's some variables that I included. These are global variables, and these had to be global variables because they were used throughout the program. And the easiest way I found to do that is global. I know a lot of the new programmers like to do everything local if they can or whatever, but sometimes you cannot. Okay, so let's take a look down here, because I may not use all these. Do I use all these? Okay, so measure 1. Okay, I think I'm not using most of these measures. I was going to try to do an averaging, but I didn't. There's a counting variable. We're creating a random number. We're having a delay, and an average. Okay, so here is the new ping, sonar, trigger, echo. So this is the thing that I guess this one sets the maximum distance. So it takes our maximum distance from up here, puts it in here. Defines the echo pin that we're going to use and the trigger pin. And then we go down to void setup, which is run once. And this is setting up our serial communication, which is really not used in this program unless you want to do troubleshooting. But we're going to have it run autonomous, so we won't use that. And we're going to attach servos to left servo to 11 and right servo to 10. And I'm using those pins because the other pins are taken up by our voice activated VR shield. So this is run once, the void setup. Then we have the void loop, and so we're starting our void loop now, and this is the part of the program that loops and loops and loops forever. And the first thing we're going to do is delay, because actually we're waiting for toward the end of the program. It's doing some ping and other stuff, so you can put the delay any place in the loop, but I put it at the beginning. And then we're going to generate a random number. So RAND capital NUMBER equals 1 to 3. And this is a little bit different than what the Arduino description was, I thought, because I would have thought that 1 to 3 would generate a random number between 1 and 3, but it actually generates a random number either 1 or 2. And we're going to use 1 or 2 to turn right or left when it backs up. Okay, and then we're going to generate a second random number. It's going to be under the delay variable, which we defined up above as an integer, delay 1, DLY1, and it's random number 1 to 6, which will actually generate a random number from 1 to 5. I'm not sure why that is, but so what that's going to do is we're going to have the robot go forward, and then when it senses something, it will back up a certain distance, and then it will choose randomly to choose right or left. And then it will choose. We kind of wanted to make it more random. So how much does it turn? So it'll between 1 to 5, it will turn that long randomly, left or right. And so the first one determines which direction it turns, and the second one determines how much it turns. So we have two different things going on there, so it will really randomize things of how the robot moves around. Okay, so we're not really using the serial port command, so this command is not important. We're going to set measurement to 0 because we're going to take kind of an average, and then we're going to use a count to let's see, yeah, we're going to use a count to count how many times it's averaging. Actually, I'm sorry, the count is not counting how many times it averages. There was some issue where the sensor was kind of sticking zeros in there, which aren't really great because the zeros are kind of like a misreading. I'm not sure why it does that. And there's also another issue where I was trying to average those out and just force it to, take good numbers, and if it got a 0, then skip it. And that's what I'm doing. Yeah, I said while it's not equal to 0. But the thing about it is, if you take the sensor and you point it so that it's some distance very far away, it just will not measure anything ever. And so I wanted to make it so it gives up after a certain amount of time and just skips through the loop and say, well, it's probably really far away, so we can assume that it's just an infinite distance or whatever. And so otherwise it will get hung up in this loop. So we'll let it count for 10 times, and if it measures 0 10 times in a row, then we'll just set the value to 200, and that will cause it to skip out of the loop. So the loop goes, while it's equal to 0, we're going to take a measurement, and then plus plus to our count. Okay, so if it doesn't measure a 0, if it measures a real number, it'll skip out of the loop and continue down. But if it keeps on measuring 0 over and over again, after 10, we're going to get fed up and say, okay, we're done. Just set it to 200, which is the maximum distance it would measure anyway, because the wall's at least that far away, and so it's not going to affect us. And so we'll skip out of the loop. And then we go down to the next part, and these are just serial prints to do troubleshooting. So we can hook it up to the USB and see what the computer's thinking inside of the Arduino here. And so we're just printing the values back that we think we're getting. Okay, and we're going to print the random number because we want to check that too. But these are not important for the program operation. Okay. So if measure 1 is greater than 13, which is saying that's 13 centimeters. So if you have this sensor and it comes up and it's at 13 centimeters, then it will that will be the trigger point. So if it's greater than that, then the robot is going to just move forward for 500 milliseconds and then stop. So the robot's going to keep on creeping forward if there's nothing in front of it. And what these numbers, so the first command here is servo left dot right microseconds, and this is writing a value for how fast the motors are going to go. Now it turns out that the motors have to kind of be tuned for the 0 point, because I wanted to have the thing stop when it's at the 0 point. So this number here, 1480, was for that particular servo. I had to tune around with it till I got that number. And then minus 200 is because one servo is on one side, so it spins one way to go forward, and the other servo is on the other side. So I'm subtracting 200 from the left servo, and I'm adding 200 to the right servo, so that they both go forward, right? Because when you change one from this side to that side, the orientation that it spins changes. And so on the second servo, the 0 point is 1495, and then I'm adding 200 to that. So these first two commands are going to make it go forward for 500 milliseconds. Here's a delay, 500 milliseconds. And then we're going to stop. So we're going to write to the servo left, right, 1480, which is the 0 point on that servo. And servo right, 1495, which is the 0 point of the right servo. So servos will come to a stop. And then, of course, we have an else statement. So this is the case if there's nothing in front of us, we're going to creep forward, and otherwise there is something in front of us, which means we're closer than 13 centimeters. So it's measured like a wall or something up here. Now remember, it won't measure stuff down here, but if there's a wall or something up here and it's come closer than 13 centimeters, and the robot says, uh-oh, we got to do the else case. And so we have else here, and we're going to check to see whether it turns right or left. So if number equals 1, we'll have it turn one way. Maybe this is right, I don't remember. And else, which would be case for number equals 2, it will turn left, and that would be this case down here. And it might be vice versa, I didn't figure it out, but one's turning one way, one's turning the other way. So what we're going to do here is the first servo rights are going to cause the robot to back up. Notice how we have the 0 point, 1480, plus 200. Up here it was minus 200, and for the right servo it's 1495 minus 200, and up here it was plus 200. So these are going, both of them are going backwards. So the robot will back up straight for 200 milliseconds, or 2 seconds. So it's going to back up quite a bit. And then it's going to back up on one of the servos, the left one. So if it's backing up on the left, it's actually turning right. So the right one's going to be set to 0, and the left one's going to back up. So it's going to turn, and it's going to turn for 5. Here's a delay that's put in here for 500 milliseconds times the delay, which is, remember, a random number between 1 and 5, right? So it might turn a little bit, it might turn a lot. So if it was a random number of 1, it would turn a half a second, which is 500 milliseconds. And if it was a random number of 5, it will turn 5 times 500 milliseconds, which is 2.5 seconds. So it's going to turn somewhere in between those ranges, and then it will stop. And the loop will start over after that. And of course, if it does the else, if the random number for the direction was chosen to the left, then it will do the same thing in the left direction, where it backs up for 200 milliseconds. Then it will turn the other tank tread, it'll turn the right one backwards. So when the right one goes backwards, it will turn to the left for a random amount of time, delay times 500 milliseconds, and then it will tell it to stop again. We put the stop values in there. And so that is the end of the program. Then of course it will go back up to the beginning of void loop, and here's our delay. We needed a delay somewhere before we do the ping again, because it needs time to recover from the echoes and all the other things going on. And so it starts the loop over and over again, checks to see, measures the ping, sees if it's too close. If it's not too close, it creeps forward. If it is too close, it backs up and turns, and it will just continue to search around and kind of explore the whole area. So it's kind of a neat little program. It makes the robot look kind of like it's alive. And so anyway, this is a kind of a neat little project with your Arduino. Now I remember when I was a kid, I wanted to build a robot like this, and there was a book in the library on how to use like flip-flops, and you had to get the individual chips and program them to do random stuff, and you had to try to find sensors and motors and just figure out how to do all that stuff yourself with just the old-time electronics and transistors, bipolar transistors back then. Oh god, we didn't even have FETs. So being able to do a neat little project like this with modular components that you can buy and program it with a slick little IDE from Arduino is just amazing. It's amazing. The future's it's going to be like Star Wars, I think. Anyway, this is Dr. Janes, and thanks for watching.